Good morning, everyone. I'm Vinitha, Associate Professor in the Department of Electrical and Electronics Engineering, RMD Engineering College. Today, I'm going to solve a problem in impedance and reactance diagram. So, draw the impedance and reactance diagram for the electric power system shown in figure. Choose generator as base value, generator ratings as base values. The three-phase and line-to-line ratings are given below. For this problem, the generator ratings, transformer ratings, motor A and B, then the transmission line data are given in this problem. And so if all the data are given, if the single line diagram which is not given also, we can draw the single line diagram using these parameters. So first one is generator. So this is the generator. And the ratings of the generator are 25 MVA, 13.8 kV, X double dash is equal to 15%. And T1 and T2 transformers 25 MVA, 13.2 bar 69 kV, XL is equal to 15%. See here for transformer it is given as 13.2 bar 69 kV. So what does this means? That is here for the transformer T1 it is 13.2 bar 69 kV, and for the second transformer it is 69 bar 13.2 kV. So this is the way we need to choose the voltage rating. Similarly for motor A, motor B and transmission line. And here in this problem itself it is given choose generator ratings as the base values. Here for the generator, the MVA value is given as 25 MVA. So MVAB new that is equal to 25 MVA, and for this generator KVB new that is equal to 13.8 kV. So for the remaining sections, we need to calculate KVB new. So let us start solving the problem. So in order to solve this problem, first we need to divide the single line diagram into various sections. So wherever we have the transformer, where we need to split the problem. So first here, mm, from the generator to transformer primary, this is the first section. Similarly, from this transformer secondary to transformer T to primary, this is section 2. And then finally transformer secondary side to this entire motor E and motor A and motor B. This is third section. And here after dividing or splitting all the sections, the ratings of each and every component that is specified here. So for generator, transformer T1, transmission line, transformer T2, motor A as well as motor B. Now the first step is we need to choose base MVA. So in the problem itself, it is given generator rating. So MVAB new that is equal to 25 MVA, and KVB new that is equal to 13.8 kV for this generator section. See here, first we can calculate the base voltage of each and every section. In the problem itself, it is given generator voltage as the base value. So for the first section, KVB new that is equal to 13.8 kV. So here for the first section, KVB new that is equal to 13.8 kV. Now we need to calculate the voltage KVB new for the second section. So for the second section is nothing but transmission line which is connected to secondary, that is high tension side of transformer T1 and high tension side of transformer T2. So that we can apply a formula KVB on HT side of transformer T1 or T2. So if it is KVB on HT side of transformer T1, then we can apply the formula KVB on LT side of transformer T1 into HT voltage rating divided by LT voltage rating. So what is the KVB rating on LT section of transformer T1? It is nothing but 13.8 kV. For this section, new kVB that is equal to 13.8. So that 13.8 we need to substitute here. Then HT voltage rating divided by LT voltage rating. So what is HT voltage rating for transformer T1? It is 69 and the LT voltage is 13.2 kV. So 39 divided by 69 divided by 13.2 kV. So if you simplify, you'll get the answer is 72.14 kV. So for the second section, the kVB new that is equal to 72.14. Similarly, this transformer T2 high tension side which is connected to the transmission line, the same voltage that is this 72.14 that will be available at the high tension side of this transformer T2. Now we need to calculate the kVB new for the third section. So for the third section, that is we have motor A, B that will be connected to the low tension side of transformer T2. So what is the formula we need to apply here? The formula is nothing but kVB on LT side of transformer T2. The formulas kVB on HT side of transformer T2 into LT voltage rating divided by HT voltage rating. Okay, this formula we need to apply. So here, if you see, so kVB on LT side of transformer T2 that is equal to kVB on HT side of transformer T2 into LT voltage rating divided by HT voltage rating. So what is kVB on HT side now? kVB on HT side is now 72.14. That value we need to substitute 72.14 into what is LT divided by HT rating? LT divided by HT rating is nothing but 13.2 divided by 69. 13.2 divided by 69. So if you simplify this, we will get the answer is 13.8 kV. So for the third section, kVB new that is equal to 13.8 kV. Now we have calculated kVB new for all the three sections. If we know the value of base MVAB and kVB, we can go for calculating per unit calculations. So for the first step, we can go for calculating the per unit reactance of the generator. So here the values are specified in terms of per unit. For generator, it is specified in per unit, so that we can apply a formula is that per unit mu is equal to is that per unit old into kVB old by mu the whole square into MVAB mu divided by MVAB old. So if you substitute all the values here, we'll get the new Z per unit value. So what is Z per unit old for the generator? It is 15%. So it is nothing but J 0.5. Why it is J 0.15? Because it is reactance. Z is equal to R plus Jx. Since the value of R is equal to 0, no need to substitute the value of R. So reactance value is nothing but J 0.15. Percentage means 0.15 into kVB old by new. So what is kVB old value? Whatever the value that is specified in the problem, that value must be taken as the old value. So for the generator, the old value is nothing but 13.8 and the new value is also 13.8. So 13.8 divided by 13.8 the whole square into what is MVB new? It is 25 divided by what is old value of generator MVA? It is 25. So 25 divided by 25 is nothing but J 0.15 per unit. This is for generator. Similarly, we need to calculate this per unit reactance for a transformer T1. For transformer T1, So for a transformer T1, if you take the values here, you can see the diagram, same formula, because here again the value which is given in terms of per unit. So apply the same formula. For this transformer 1, Z per unit old is nothing but J.15 into uh, what is old value of this generator? It is nothing but 13.2. So while calculating the per unit value of transformer, we can consider the primary side, low tension side or high tension side, whatever may be, we will be getting the same answer. Okay, so here it is taken, it is considered as low tension side of the transformer. So KVB old is nothing but 13.2 and KVB new is nothing but 13.8 the whole square into MVB new is nothing but 25 and that is for a transformer it is given MVAB old is nothing but 25. So if you simplify this we will be getting the answer as J.137 per unit. The next component is transmission line. So here we have the transmission line. So in order to calculate per unit reactance of transmission line, we have to check whether the impedance value, old value, which is given in per unit or in ohms. So if you see for transmission line, which is given in terms of ohms. So what is the formula we need to apply? Z per unit mu is equal to Z actual divided by Z base. Z base is equal to KVB mu the whole square divided by NVAB. So we will be getting this formula. Now you can substitute the value here. Z per unit mu is equal to Z actual. That is nothing but 65 ohms into MVAB new. What is MVAB new for this transmission line? It is 25 because MVAB is common to all the components. So it is 25 divided by KVB new the whole square. So what is KVB new for this transmission line? It is 72.14. So 72.14 the whole square. If we substitute, we will get the answer is J.312 per unit. Next, transformer T2. So for this transformer, again the reactance which is given in terms of that is per unit. So we can apply the same formula. So Z per unit old. What is Z per unit old? It is 15%. That is J.15 into KVB old by new the whole square. So for this transformer T2, what is old value? Here also it is taken as high tension side of the transformer T2. High tension side means old value is 69 and new value is 72.72.14. That is, this is your high tension side of transformer T2. So here this calculation which is based on high tension referred to high tension side of transformer T2. High tension side of transformer T2. Okay, so if the formula is applied and if we substitute the value for this high tension side, the old value is nothing but 69 and the new value is 72.14 the whole square into MVA the new is 25 and the old value which is also 25 for transformer T2. So if we calculate we will get the answer J.137. And the next step is motor A. For motor A, we need to check whether the values are given in terms of ohms or MVA, that is per unit. And here also the value which is given in per unit. So use the same formula. So in order to find the value, we need to check the old and new values. So S per unit old is equal to J.15. And what is old KVB? It is 13. What is new KVB? It is 13.8. So substitute the value here. And then we can substitute the value for MVAB new and old. New is same, it is 25 MVA. And what is old value? For the first motor, it is 15. So if you substitute all the values and calculate it per unit, we will get the answer J.222. Similarly, motor B. For motor B, MVB old is nothing but 10 and KVB old is 13. So substitute all the values here, and if you calculate, we will get the answer is point J 0.333. Now we have calculated Z per unit new for all the components connected in the single line diagram. So what is the next step? We need to draw the impedance and reactance diagram. So first step is impedance diagram. So for the impedance diagram, what is the how to draw the impedance diagram? We need to neglect all the resistances. So since in this problem we don't have any resistances, no need to include the resistance value. Just we can draw all the represent all the components in this impedance diagram: generator and its reactance, transformer T1, transmission line, transformer T2, motor A, motor B. For each and every component, all the reactance values are specified in this impedance diagram. Similarly, reactance diagram. So in this reactance diagram, there is no change because since we have not used any resistance value, the reactance diagram also same diagram. Okay, so this is the procedure to calculate the per unit impedance from a single line diagram and to draw the reactance diagram. Thank you.